Hey YouTube, I'm back from my trip. I'm here, back in my studio, back in my chair. Feels really good. Feels comfortable. It was really wonderful experience that I had out in Italy, but I am more than excited to get back into some real development. It's been a while. I've had plenty of time to let my mind rest and float and go where it needs to go. So yeah, today it's Saturday, but it's a wonderful rainy day. I think it's supposed to be raining all day, so I'm going to. This is a perfect day. Start up the stream and get some code done. So hopefully I'll see some of you on there. If not, I'll be recording my progress throughout the day. Okay, here we go. Breakfast is melting, so let's just take a look at the to-do list here and see where we're at. So on the plane ride home, I got to do a few things. I got about 6 or 7 hours of actual programming in, as much as, I mean, it's not that comfortable to program on a laptop in a plane, but I got something done, so let's take a look. Okay, I've got a little task list here that I wrote while I was on there. So, I mean, on here I've got like finished kinematics, lateral recoil, so when you shoot, the ship actually moves backwards kind of thing. Impact damage, bullet collision, a whole bunch of different mechanics. The truth is, once I started working, I quickly ran into performance issues on my laptop. It's quite a bit of a slower computer than this, obviously. But also I had it in the lowest power state so that I could run on the battery the whole flight, which was really great. Having a laptop that you can program on for like, I don't know, I did 6 hours. I probably had another 4 or 5. I don't know. I could have gone for like another 8 hours just on the laptop battery, not being able to plug it in. It's really nice. But I had to figure out how to get the game to run quickly enough to be able to test my changes on the low power state. So, and obviously this is a really good thing to do right now because I'm targeting a mobile platform, the Oculus Quest. So I didn't feel bad at all about spending time on the performance. So it took all day, but the performance is where it needs to be at on my laptop, which is really great because now I can develop and test on the laptop on the low power state without any issues. For now, at least, until I add more complexity that makes it slow again. But I did also have a bit of time to add one mechanic, which is the recoil, which I'm really happy with. It took no time at all, but as you can see when I shoot, there's quite a significant recoil pushing me backwards, and it feels really good. I'm pretty excited about this. I have this idea of how the game is going to work mechanically in my head, and this brings it one step closer to that imagination. So a few more features and we'll be there. And so hopefully today we can get a bunch of little mechanics done and get that gameplay closer to the vision. Got a few little bugs to work out once we finish debugging this navigation stuff and take a look to see if that also solves an issue that I'm having with the gravity integration. If not, we'll fix that and then we will continue down this list of features to implement. Okay, with all that said, let's get the stream going and get some of this work done. I'm really excited to do this, by the way. It's gonna feel really good to get some more coding done. Okay, quick explanation of what's going on, the bug I'm trying to fix. Okay, let's say we have these 3 shapes, or these edges in the polygon, right? Like these are all edges. Okay, so right now the algorithm is taking these, it's splitting them at any intersections, right? And it knows who or which lines belong, or which segments belong to who. So you might say that this one is 1. That's Mr. Red, and this is Mr. Yellow over here, right? That's terrible, but I'm on a mouse, what can you do? So I split all the segments at the intersections so that they're all separate, and then I go through and say, is this segment within another polygon? And so this one is, and so we would just remove that guy and not use it for the simulation going forward. And we can remove that guy, and we keep this one, and we keep this one, and we keep this one, and whatever, so that we end up with this instead of what we had before. And we also actually get rid of these guys. So this is what we want to end up with for the navigation to work properly. I mean, you can kind of, at the end of the day, we're trying to get, oops. At the end of the day, we're trying to get this path here. Now, the problem is, now that our map is not strictly convex, this guy might be red, right? And this guy might be yellow. But this guy over here is also part of that yellow. It has the same ID. It's from the same mesh as this guy, because it's because the mesh isn't convex. We might get two shapes, two-dimensional shapes out of a slice of it. So this kind of fucks with things big time, because when you're trying to evaluate, say, this segment here, it might appear that it's outside of the yellow shape because it's outside of these ones over here. Like, the math just doesn't work well. So I've got about 3 options, I think. One is to do another step in the algorithm to separate these things. So this might be red, and we've got yellow, and then we've got Mr. Blue here, so we can separate the yellows, and I'm sure there's some kind of math I can do to separate these shapes. That's not great for performance, probably. I don't want to add more complexity. Option number 2 is to simply author the map differently so that it is all convex shapes, and then I can just roll with what's there and not worry about it. And option number 3 is trying to figure out some other some other math that I don't know yet to solve this issue, and to kind of get rid of these segments that I don't want without doing the same algorithm that I'm doing now that relies on convex shapes. So pragmatic me is saying, fuck it, just figure out how in Blender to break this mesh up into convex shapes. And I think that's what I'm going to do, because it's the least amount of work, and I'm not too worried about having an extra step in the pipeline for building maps. So let's do that. Let's figure that out. Let's see if I can do that in Blender first of all. Okay, I just spent about 2 hours on stream trying to tackle this issue. I was trying to make my map all convex shapes to work better with the algorithm, as I mentioned before. I spent some time trying to get a plugin working to generate this automatically. Didn't work out. That plugin's not really meant for what I'm trying to do. I want the exact geometry, but that plugin was giving me a little bit of a expansion on it, more for use in like physics simulations for, you know, tumbling rocks and stuff like that. So I just did it by hand, which was no big deal, and I should have done that from the start. But testing that with the individual shapes here, it still doesn't really work. So either there's something else to the bug that I'm not seeing, or it's not related to the convex issue at all, and I'm stupid, or my shapes aren't convex enough. That might be, I don't know. I'm not sure if that's the issue. So I'm gonna go actually eat, because I haven't eaten yet, and then I'm going to come back, break this up some more just to verify, make sure everything is like super convex, make sure everything's like, I'll make it all triangles if I have to. See if that fixes the bug, and if not, dig into the code more and see what the issue is. And we're back. So I did some more Googling and figured out that what I really want to do is implement an exact convex decomposition algorithm. Probably implement it in the game code at the startup, so I can take the meshes, break them up into exactly what I need for the algorithm, or for the navigation to work properly. But before I do that, I'm going to do it manually and make sure I clean up some of these examples of still concave meshes, and make sure that that's actually going to fix the problem before I go putting that
before I go putting that work in. Yeah? Okay. Anyway, stream is going live and we're getting into it. Okay, so I finished convexifying the map, all the meshes on it. 100% definitely, they're definitely convex. But it didn't quite fix the problem, and I've noticed another issue. The problem is that we're not considering this entire mesh's slice. We're calling out some of the triangles. These triangles, if you see my mouse. We're calling those out from the navigation line because they're far enough away that we don't really need them. However, that's confusing the part of the algorithm that determines whether this is eligible or not, because it thinks it's inside of this mesh. So you can see it works, everything works fine once this entire shape is being sliced, but when only half of it is, we get a problem. So not quite sure what I'm going to do about this yet. I'm going to take a look at the code and, wow, I said that really fast. Did you hear that? Take a look at the code. Interesting. Yeah, I'm going to take a look and see what I can do about this. Obviously, one thing I can do is consider all the triangles in the mesh, always. But the way I've got that set up now might be tricky. Anyway, let me do some digging. So I was working on this triangle calling thing, and I noticed that even while we were aggressively calling triangles, there are still some situations, some spots in the map where the whole map needs to be considered, like all the triangles need to be considered. And so I've come to the conclusion that we're just gonna not call any triangles. There's a concept that I try to adhere to, which is optimizing for the worst case. There's optimizing for the best case where, you know, our guy might be in a certain position where we don't need to consider most of the map and we gain a whole bunch of performance because of that. But that depends on where the player is on the map. So we want to make optimizations that don't depend on that. We want to avoid frame rate dips, and we want it to be fast no matter where the player is. So we're gonna go with option 4 here and just remove, well, we'll do this. I'm just gonna delete the culling. I'm also gonna stop drawing it because we don't need to anymore. And now it should work reliably with less code. A little bit less performance in certain situations, but we're gonna have to find a way to make it run fast in all situations. Okay, we seem to be working pretty reliably now. And there's still some bugginess with the slopes going up and down, and that's a separate issue entirely, it seems. But I think I'm gonna leave that alone for now and try to focus on some more fun stuff. So looking at the to-do list, this guy is done for now. I'm sure I'll find more bugs later in the navigation code. But the next thing on the list is to improve the recoil pattern and make it deterministic for net replication. So the network code relies on determinism of the simulation to make it a lot more efficient. Which means if I give some inputs here and I send those inputs over to my brother playing on another client, he'll get the same output and the same simulation state. The bullets will go in the same direction, the people will be in the same positions, and everything else like that without me actually having to send that information over. But right now, the last thing in the simulation that's not deterministic is the recoil. So when I shoot, you can see the angle jitters all over the place. Right now that's just done using a randomization call. So I'm going to make that deterministic instead, and I'm also going to try to make the recoil pattern a little bit more meaningful than just pure random. I'm going to try to make it something that you can learn to negate and kind of get used to, and down the line, if there's different weapons, there might be different recoil patterns, just like in Counter-Strike or something like that, where there's some more skill depth or more learning to be done with that, and that should make shooting a little bit more interesting. Actually, before I jump into that, I want to try, since I spent all that time making the meshes on the map convex, because I thought that might fix my issue, I'm curious to see if that had anything to do with it at all. So I'm going to go in here and revert that. Undo changes, yes. And let's see if it works properly with a non-convex map anyway. Right, so that appears to be pretty reliable, so that's good. Actually, despite that meaning that I wasted a bunch of time, it does mean that I can waste less time in the future and not have to make my maps perfectly convex shapes, or a collection of convex shapes. Okay, so I figured out a pretty good design, I think. I got some interesting ideas for how this recoil is going to work. At first I was had no idea what to do with it, but after doing some writing to myself, you can see here, if you want to pause it and read it, you can. Got some interesting ideas for how this is going to work. Unfortunately, I need to go away from the house right now, but maybe later tonight I'll be able to come back and try it out, and I will give you an update if that's the case.